Hello, and welcome to Impact-Oriented Programming. I really appreciate you taking the time to check out this video for the project that I'm currently sponsoring with the INI. First, who am I? My name is Adam Cicchetti. I've been an entrepreneur, founder, CEO, hacker, and father. I've worn many hats and titles over the years. I've had a wonderful 20-year career in technology as an entrepreneur. I was part of the INI as the MSIN 15 class. Had a really great time and cherished my time at CMU. I built a company called Deja Vu Security that eventually was exited to Accenture in 2019. Built another company called Peach Tech that was exited to GitLab in 2020. I spent a little bit of time at both Amazon as an engineer and Accenture as a managing director. And I'm currently working on a book called How to Think Like a Hacker. But I'm also working on this project, Impact-Oriented Programming. And the idea behind this is to really change how we fundamentally think and interact with computers when we're building systems. If you've built anything of note, you've probably ended up at one point in your life in the UWOL debugging loop. Why is it doing this? That's not what I wanted. What is it doing? It can't do that. That's not how it works. And then sometime later, whether it's 3 seconds or 3 days, or in my case, 30 years, eventually you realize, oh, that's what's wrong. But how do we get there? Well, classically, we get there with a whole lot of printfs or some other mechanism like a debugger. And the problem with these two things is that even when we read the documentation and we use printf or we use a debugger, that the information ratio is broken. We're sending tiny bits of snapshots of context back to ourselves. And so what I need to see versus what I'm shown has an incredibly small ratio of things that are useful for me to actually understand what is going on in the system and to actually debug the problem. Well, part of the issue is our debuggers are still designed for a hardware abstraction layer. They were built to be very close to the machine and have a very near understanding of exactly how the computer is operating. And then we have to continue to build the idea and the context on top of that. As complexity explodes, as everything becomes more and more abstracted into whether it's a cloud service or machine learning or into the metaverse, being this close to the machine and debugging systems simply does not work. So how do we tend to figure anything out? With 8 windows or so of scrolling hacker text. But when we have these windows open, or we have logs, or we do a ton of printf debugging, what has fundamentally happened is we've stopped debugging the computer and we've started debugging ourselves. And to be able to do that faster, quicker, more reliably, we need to be able to see much more context that is needed versus what we were shown. So I'm going to introduce the idea of impact-oriented programming. The idea that the most important thing to me is what impacts does my intended code make to the machine? Or said another way, is the code that I've written making changes in the machine the way that my brain is assuming the machine works? So this project is going to build a lot of plumbing to try and build a prototype that presents an interface to the user to be able to not only debug the machine while creating code, but also to make communication between what's happening in the machine and how the machine is actually at work a faster, more reliable, more communicative feedback loop. So how are we going to build this dialogue machine? Well, first we need to understand what is this code doing. And that's a combination of docs, IDE, some static analysis, and a REPL. Then we need to know what the code does under various circumstances. Understanding what the function you assume to do does under the happy path or under good inputs are great, but we really need to understand how this code works on the edges of boundaries of input or arrays or of allocations. And then finally, we need to understand how this code is going to make changes to the machine fundamentally. So we need a way to look and inspect and debug this so that we can know, are our changes bounded? Will this return all records in the database? Will this overwrite all memory? Are these changes safe? Or, but most importantly, are these changes in the machine that I wanted when new input that maybe I didn't expect occurs? So what is the impact of this project? Why is this interesting? Why would you want to work on this? If we make this prototype right, we will fundamentally change the way that people build with computers forever. I'm hoping that we can shorten the amount of time that it takes a person to learn how the machine is working and then be able to change and learn and build code faster and better as a result. So who are you? What are the skills I need? I need someone that understands what an AST is and how to hook into the compiler so that we can get the contextual information that we need to understand what changes are being made. Someone that knows and understands what a fuzzer is, how they work, and how we can hook into that to be able to automatically fuzz some of the code that's being generated. How are we going to build some of this? Well, we're going to put it inside of a REPL, most likely extending a Jupyter notebook, but I'm open to understanding the trade-offs of other ones to see what some of the design decisions we can make there are. As well as we'll need someone to help extend a UI interface to make this useful. But mostly, I need you to be comfortable with being uncomfortable and diving into programs and libraries in different places and writing the glue in between them so that we can connect these and build something that has never been built before. Thank you. I really appreciate you taking the time to listen, and I look forward to talking to you more about this project.